All right, so we're going to use the abbreviation CPCTC, and what it's going to do is like the converse of what we were just doing. Once you get triangles congruent, we'll be able to prove parts of them are congruent that we didn't know before. So what is the CPCTC? It is just an abbreviation for a phrase, and that phrase is really coming from the definition of congruent polygons. Why don't you flip back a few sections? Can you find that definition of congruent polygons? I think it was, which section there? 4.3. Section 4.3. Congruent polygons. Two polygons with corresponding angles and sides congruent. So when we were on that section, you had to get all the parts, all the angles congruent, all the segments, the sides congruent, before we knew that the triangles or rectangles or pentagons, any polygon were congruent. Okay, that's really saying the same thing as this. Just think about it. Corresponding parts of congruent, I could say polygons, are congruent. That's saying the same thing that that definition is saying, just specifically about triangles. The corresponding, the matching parts, if the triangles are congruent, the matching parts have to be congruent. But it's kind of a fun little phrase to say, CPCTC. I'll guarantee there's a question on the test that says, what does, or give me the phrase for CPCTC. So you need to learn corresponding parts of congruent triangles are congruent. Think about it. Corresponding parts, matching parts of congruent triangles are going to be congruent. So let's say it together 3 times. You can read it from the board. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. That's the phrase you need to learn. All right, this will be a reason that you can use in the proof because it's basically the definition, just said in an abbreviated way. It can be used after you have proven 2 triangles congruent, because look at your phrase again, corresponding parts of congruent triangles. So you need congruent triangles. Then the corresponding parts are congruent. So this will be used after we did what we did for today. So, for instance, we've got these proofs up on the board. I'll just kind of point to this last one over here. Like number 8 is close. We got angle A congruent to angle C. We got angle ABD congruent to angle CBD. We got our segment DB congruent to segment DB. So that gave us triangle ABC congruent to triangle CBD. All right, that's kind of a summary of the proof that's on the board. Well, once we know these triangles are congruent, there's 3 more parts now we would know are congruent that we didn't know before. What angles, let's see, here's one pair, here's one pair. What angles are congruent that we haven't stated? See, A was congruent to C, yes. B congruent to B. So evidently now we know that angle C is congruent to angle D. We didn't know that up there, but we can come up with it now. Did I label these correctly? CPD, CPD, AB. Oh, this one shouldn't be ABC. I was writing what they did. ABD. Oops. I didn't catch that when I went through it on homework. ABD is what this should have said right here. But now I was trying to explain what I'm doing. It wasn't matching up right. Okay, so we now know that the angle D and the angle D are congruent. Why? Well, because they're the corresponding parts of the congruent triangles. So they're congruent. We knew segment DB, congruent to segment DB. So now I also would know segment AB is congruent to segment CB, because they're the corresponding parts of the congruent triangles, so they're congruent. And I also would know segment AD congruent to segment CD because they're the corresponding parts of the congruent triangles, so they're congruent. So we use these three facts to get the triangles congruent, the angle side, and then we had three more things that we can come up with that we didn't know before. And those are all supported by CPCTC. So that's what we're doing today, is going beyond the triangles. Make sense? It's after the triangles. So let's try, I guess this is my summary. You use those abbreviations or those theorems to get triangles congruent. CPCTC uses congruent triangles to get the parts congruent, so it's kind of like they're converses. Here's just a real life situation that could be used, this relationship could be used at. A landscape architect sets up the triangles shown in the figure to find the distance across the pond. Okay? Wouldn't be able to measure that directly. What is the length of JK? Well, are the triangles in this picture congruent? JL is congruent to LN, right? They're both 19. ML is congruent to LK, they're both 30. And don't tell me that MN and K or JK are congruent, because I don't know what that length is. What else do you know about the triangles, though? What's that? Vertical angles that are congruent. So your two triangles are congruent. I'll list them in the right order. JLK would be congruent to triangle. Does it start with M or N? N. NLM. Because of side angle side. Now you should be able to support that segment JK would be congruent to segment MN. Why? They are the corresponding parts of the congruent triangles, so they're congruent, correct. So then we can say JK is 41 feet. So we got the triangles congruent so that we could get the segments congruent. All right, let's try that. Some actual proofs today. Okay, probably start writing on your page. And notice the given information is like what we were doing yesterday, but what we're trying to prove is different. I'm going to have to probably write it on the board as we go through the proof. What does the first C in our phrase stand for? Corresponding. Last C in the phrase. Congruent. Okay, got it written down? Do you want to see 2-column or flowchart proof? Stick to 2-column. Statements, reasons. Now notice what we're trying to prove. We're trying to prove segment PQ congruent to segment PS. Now if this segment bisects the angle, actually it bisects two angles, doesn't it? Connor, when we bisect an angle, what do we get? Do we get congruent angles or congruent segments when we bisect an angle? Okay. So I want you to realize this given information does not directly tell us that these segments are congruent. So what we're going to try and do is use the given to get the triangles congruent, and then we hopefully will have these two parts match up. They're the corresponding parts. So we'll use the CPCTC at the end. Okay, tell me what to write down. Should we just start with the given? Okay, number one, given segment PR bisects angle QPS and angle QRS. Reason? Given. Okay, now we have to interpret that. So what are we going to interpret? We're going to use the definition of angle bisector. Probably twice. Definition of angle bisector. Okay, so let's go one part at a time. If PR bisects angle QPS, that's the angle on the left, what segments, or excuse me, what angles are congruent when we bisect angle QPS? Angle QPR and SPR. So angle QPR, we're up to angle Q or SPR. QPR and SPR. Let's bisect the other one, since it's the same reason. If we're bisecting angle QRS, the one on the right, Lucas, tell me which angles to write down. Are congruent. It ran out of given. Another idea? You know something else about those triangles yet? They're hooked together, aren't they? They've got a segment that's the very same, no matter which triangle you're thinking of. What segment am I looking at? See the PR they're telling you? PR is the side of the top triangle. PR is also the side of the bottom triangle. That segment PR is the same in both triangles. So how do we write that down, class? Segment PR is congruent to segment PR, supported by, you said reflexive property. Reflexive property of congruence. Are the triangles congruent yet? Yes? Okay, so triangle. If I call the first one PQR, it's congruent to triangle PSR would be the matching order. Now, normally on yesterday's they gave us that, but they're not giving you that on today's. We have to match it up right. Our reason? Side angle congruence postulate. Now we're not done because that's not what we were trying to prove. What are we trying to prove? PQ congruent to PS. Are they matching in our triangles? Let's see if we listed it. PQ, PS, they do match. So we should be able to say segment PQ is congruent to segment PS because of CPCTC. Okay, class together, what's that stand for? No, first one's not congruent. Corresponding parts of triangles are congruent. They're the corresponding parts, they're the matching parts. So in the end, we got this segment congruent to this one because they matched up after we got the triangles congruent. Question? That was my proof. I had put it in a or in a flow chart. Okay, let's try this one. Okay, Z is real small on my picture. All right, we're given that YW bisects segment XZ, and then XY and YZ are congruent. We're trying to prove angle XYW congruent to angle ZYW. Anyone still need the proof on the board? I think I'll start with some of the given while you're writing all that down. Segment YW bisects segment XZ. I'm going to go down here and put the other part. I'm not putting all the given in the same place because I think we're going to do different things with it. So I'm starting with the first given, segment YW bisects segment XZ. Okay, if we bisect segment XZ, that means we're cutting segment XZ in half. Does that make congruent angles or congruent segments? If we bisect segment XZ, that should make two segments that are congruent. Okay? Bisecting an angle makes angles congruent. Bisecting a segment makes segments congruent. What is something else I could have in this proof rather than saying it bisects? Couldn't I say that W is a midpoint, and that would do the same thing, cutting it in half? So I could start you off with different wording, but you came up with the same information. Okay, so what do we want to say? We want to say, if this bisects it, segment XW is congruent to segment ZW. So my number 2, segment XW congruent to segment WZ. I don't know if I said that right a little while ago. What's my reason? Okay, what about it? Definition of segment bisect. Then I put the next given. Why is it spaced out funny? Because I didn't renumber, I just erased from the last one. So segment XY is congruent to segment YZ. That was also given. Okay. Okay, segment YW congruent to segment YW. Definite, or excuse me, would you say reflexive property?
Reflexive property.
Property of congruence, yes. Okay. Okay, she's thinking we can use side congruence postulate. What does that support, Morgan? Congruent to. You said XYW twice. See? Did she match it up right?
No, it's ZYW.
Should be ZYW. Let's see, she went X, YW, ZYW. Correct, that's the correct matching now. That's not what we're trying to prove. It kind of looks like it, but we're trying to prove angles congruent, not triangles. So we're not done. I know with the 3 letters, it's kind of gets confusing, but this is basically angle Y and angle Y in the 2 triangles. Do I have those matching? Angle Y and angle Y? Yes, I do. So we should be able to say angle XYW, angle ZYW, and the reason, which stands for corresponding parts of triangles are congruent. Alright, one more sample and then let's work. Alright, that was my proof. Okay, let's do this one. It's got a few different things in it. And then I'll just make sure that there isn't something in my examples that I didn't talk to you about. I think there's one on a graph, so we'll just take a look at that, how you would do it. Okay. Alright, now we've got some midpoint information. And we're trying to, oh, look what we're trying to prove. What are we trying to prove? Yeah, we're trying to prove parallels. The CPCTC support parallels. Corresponding parts of congruent triangles are congruent. It doesn't say are parallel. So how are we going to get parallels? Do we have anything, or what have we studied that concludes then the lines are parallel? Converses of like corresponding angles, alternate interior, alternate exterior, same side interior. I think we also in that same chapter some special ones that had like dual parallels theorem and dual perpendiculars. But if we don't have perpendiculars or other parallels, those really won't. It'd probably be a converse at the very end after CPCTC. So this one goes a little bit further. Okay, let's start with the given. J is the midpoint of segment KM and segment NL. Do we need to look up our definition to interpret that correctly? We need to interpret what a midpoint's going to give us. So definition of midpoint. What's that definition going to provide? Look it up quick. Morgan's looking. What's the definition of a midpoint? JK and JM congruent? Can you read it for me? Okay, so we should get two congruent segments. So Hendrik was saying KJ, I think you said?
Yeah.
Segment KJ congruent to segment JM? Because that would be it, the midpoint of KM. It's also the midpoint of NL, so look at NL. Each half is going to be the same there. So segment NJ is congruent to segment JL. What's the reason for that? Okay, so if it's still definition of a midpoint, I could just keep that in line 2, or I could make it a 3 and rewrite the reason. It's up to you. So these two are congruent, these two are congruent. Don't mark them all the same. Mark separate ones congruent. Okay, what else?
KJN is congruent to LJM. Transverse. Reflex.
Okay, are you talking angles or triangles or what?
Angles.
Angles? Okay, so he's looking at some angles. I think he named these two angles vertical angles theorem. Could be these two angles, right? Let's try and figure out which ones might help us. So hold off just a second. We are going to use vertical angles in here. We want to prove KL. We want to get this one parallel to this one. And we said we'd probably do the converse of one of those angle pairs. So would this angle congruent to like this one help get the parallels I want? No, because that's made with different sides. So I don't want those. What I'm trying to figure out is, it's not this triangle and this triangle that I'm interested in. It's really the top one and the bottom one, so that I can get to the parallels I want. So when he's thinking vertical angles, he needs to be naming this one and this one. Those are the two that are gonna help us get some angles in the triangles that we want to get the parallels. Okay, so I'm thinking ahead a little bit. All right, so angle. Okay, JL, congruent to angle NJM. And Hendrik, what was your reason? Vertical angles, 0. That says vertical angles are congruent. So what do we know right now?
The triangle KJL is congruent to triangle NJM.
Are you with him? KJL, now did he name it in the right order? KJL, NJ, I don't think he named it in the right order. MJN, looking at what segments have to match. Wouldn't it be that way? This KJ is supposed to match with MJ, KJ with MJ, so it had to start with M. Okay, what's our reason for the triangles congruent? Side angle, side. Congruence postulate. Now typically, what did we do after the triangles? Okay, so we are going to do that again. Let's see what corresponding parts are going to help us. What's going to help us get the parallels? We said those converses of something with angles. So I don't care about the other segments. I don't care that they're congruent. I want another pair of angles that are congruent in this picture. So in the triangles that we got congruent, what would be another pair of angles? Now let's see, angle K of this one matches with angle M in the other one because of CPCTC. So angle, I can't just say K, so let's see. LKJ, congruent to angle NMJ. Are you with me? That's not because of alternate interior angles, that's because of the matching parts in the triangles. We don't have any parallels. I'm trying to get parallels. So now, what converse are we going to be using that gets the parallels? Converse of alternate interior angle. And that gets the parallels, KL and MN. We had to be careful to use the correct parts. So that one's to show you CPCTC is not always the end of a proof. It could be that you just have to pick out what parts are going to help you so that you can finish proving what you're trying to prove. All right, give me a thumbs up or down. How are we doing? Some kind of. All right, I think it's time to, let's make sure that I didn't forget something just as I'm clicking through a couple more examples. I had a lot of proofs just in case we have time for them. Okay, this type, you did something like that on maybe day before's assignment. You first got the triangles congruent, which is probably what you'll have to do again. How do you get the triangles congruent? Probably calculate how long every side is. So you've got some distance formulas to do. And notice what you're trying to prove, the angles are congruent. So we're going to take those two triangles, do the distance formula. So here's all of a sudden, don't you wish you could calculate that quick? All of the answers. So these two are congruent, these two are congruent, and these two are congruent. So it seems like we have side, side, side congruence. That's what this says. So the triangles are congruent by side, side, side. which then gives me the angles E and H congruent by CPCTC. So it's doing the same thing